lots of problems and theories related to the limits, and so let's start the video by showing you the first presentation. This is very interesting interesting thing, which is called as trigonometric limits, right? In this particular limit, we will solve some of the problems related to limits in trigonometric format, right? So trigonometric limits means actually there are some formulas related to trigonometric limits. Suppose if you will get limit x tends to 0 sin x upon x, then that particular thing is equals to 1, right? When sin x upon x will be there, then that part is equals to 1, right? So this is a formula which you have to remember. We'll have some proof on the last lecture or on the later videos. Just please understand that these are the formulas where this x and that particular x should be same, and you can see when I put x equals to 0 on the numerator, then that sin x is actually tending towards 0 and the denominator will also tending towards 0, right? So limit x tending to 0 sin x upon x is equals to 1, right? So then most of the guys will say, sir, sin x upon x is equals to 1 when limit x tending to 0. Then can you say, like, when limit x tending to 0 sin kx upon k, what will be the value of this, right? So basically we can write down this particular limit as limit x tending to 0 sin kx, right, upon, we have to multiply this x with k and we have to just multiply this function with k. Now you can see that k and k will be cancelled out, and we will get the previous equation, right, previous limit equation. And now you can say that x is tending towards 0, right? So you know, right, as x tends to 0, kx will always tends to 0, right, because k is a particular constant term. So we can write down this particular thing as kx tends to 0, right? So that will be sin, and k, since k is a constant term, so it will be outside of the limit, right? So it will become k times limit kx tends to 0 sin kx upon kx, right? Now you can see that particular thing is equivalent to this particular formula, which is limit x tending to 0 sin x upon x, right? So that particular thing is nothing but equals to 1. So what value we will get? We will get k times 1, right? So that is nothing but equals to k, right? Is that right? Yeah. So basically you can understand, like when we have limit x tends to 0 sin kx upon k, that is nothing but equals to k. So we will use this formula and this formula in the later video just by putting the value, right? So can you tell me, like, what will be the value of this particular limit? So here you can see that we have limit x tends to 0 sin 5x upon x, right? So instead of k we have 5, right? Instead of k we have 5. So what will be the value of this particular limit? It is nothing but 5, right? You can understand. So similarly, instead of k we have minus 5 by 2, and limit x tends to 0 sin minus 5 by 2 x upon x is there. So what will be the value of this particular limit? It is nothing but minus 5 by 2, right? So now you can understand that how we can apply these formulas in different questions, right? Okay, let's move to another formula. This is also very interesting formula, which is limit x tends to 0 tan x upon x is equals to 1, right? So this x and this x should be same, and tan x upon x type of form, when this particular x tends to 0, then that particular thing will tends to 1, I mean equals to 1, right? So how it is coming? Just I will give you the proof here. Just basically, since limit x tends to 0 tan x by x, that function is given to you. So basically we can see that when we put x equals to 0 on the numerator, then that particular numerator will become 0, right? Similarly, the denominator will become 0, right? So basically that is called an undeterminate form, right? So now what we can do is limit x tends to 0 tan x can be written as sin x upon cos x, right? And on the denominator we have x, right? So now we can see that limit x tends to 0, that can be written as sin x upon x into 1 by cos x, right? That can be written like that we can write down, right? We can write. So now you can see that this is a function and this is a function. So limit can be, we can change the limit, right? So I mean limit x tends to 0 sin x upon x times limit x tends to 0 we have 1 by cos x, right? So now you know, right, this particular thing is equals to 1. And now if we put x tends to 0, I mean if we put x equals to 0 on the denominator and numerator, that will basically become 1 upon cos 0, right? And cos 0 value is what? 1. So that it become 1 times 1 upon 1, that is nothing but 1, right? So now you can understand that how we can get limit x tends to 0 tan x upon x is equals to 1, right? Similarly, can you tell me like what will be the value of limit x tends to 0 tan kx upon x? It is basically, since x can be written as kx tends to 0, right? And tan kx is there. So we have to first multiply this x with k, and we have to multiply it with function with k, right? Then after cancelling this k and k, we will get the value. So we will get the value. We'll get this previous one, right? So k will be outside of the limit, and we will have k times limit kx tends to 0 tan kx, right? Tan kx upon kx. Now you can see this is actually is of the form like this, right? The previous one, right? So that is nothing but equals to 1, right? So that will become k times 1, which is nothing but equals to k, right? So you can understand how. So basically limit x tends to 0 tan kx upon x is nothing but equals to k, right? So can you tell me like what is the value of limit x tends to 0 cos x? So basically at first I always told you that you have to first use the substitution method, right? If substitution method, after substituting the variable with constant, like if x is tending towards 0, then x is the variable and 0 is the constant term, right? I mean the tending value, right? After putting the tending value, if you will see that this function will give you any real number or infinity or minus infinity, then basically you have to say that this particular limit value like this. And if that particular function will give you in undeterminate form, I mean infinite by infinite, 0 upon 0, 0 to the power 0, these type of function, then basically you will say that this is nothing but an undeterminate form, right? So basically when we put x equals to 0 on that function which is cos x, so it is basically become cos 0, right? And cos 0 is nothing but equals to 1, right? So the value of this particular limit is nothing but 1, right? And by the substitution method, say by the substitution method, right? Now you can understand what am I trying to say, right? Okay, so let's move to the next slide. So there are some problems which we will discuss in this particular lecture. So basically the problem says limit x tends to 0 sin 2x plus tan 3x upon x minus tan 5x, right? So basically there is no any exact formula, but we can put 0, x equals to 0 on the numerator and the denominator, right? So when we put x equals to 0 on the numerator, you have to calculate these things in your mind, right? You don't need to write down all these things. So basically when you put x equals to 0 on the numerator, I mean sin 2x plus tan 3x, so it will give you sin 0 plus tan 0, and the value of sin 0 is nothing but 0, and the value of tan 0 is nothing but 0, right? So 0 plus 0 will be 0, so the numerator will become 0. Similarly, if we put x equals to 0 on the denominator, it will give you 0 minus tan 0, right? So that is nothing but 0 minus 0, which is 0. So basically after substituting the value of x on the numerator and the denominator, it will give me 0 upon 0, right? So 0 upon 0 is nothing but undeterminate form, right? Or undeterminate form. So we can't solve by substituting the value. So how we can solve this particular question? That is a very important question. Basically we know the formula of sin x upon x, tan x upon x, right? So dividing, so the basic things is dividing the numerator and the denominator by x, right? If we divide the numerator and the denominator by x, what we will get? So basically we get what? Limit x tending to 0, right? Sin 2x plus tan 3x upon x, right? And on the denominator we have x minus tan 5x upon x, right? So now we can write down this particular thing as, let me write down on the left side, because then we will have more spaces. So that can be written like limit x tending to 0, we will have sin 2x upon x, right? Sin 2x upon x plus tan 3x upon x, right? And on the denominator what we have? We have x upon x, right? X upon x, so which is nothing but equals to 1, right? So on the denominator we have 1 minus tan 5x upon x, right? So now you can see that there is actually lots of functions, but this is the numerator and this is the denominator. So we can change the limit on the numerator and the denominator. So it will become limit x tending to 0, we have sin 2x upon x, right, plus tan 5x upon x, I mean tan 3x upon x, just hold on, yeah, tan 3x upon x, right? Similarly on the denominator we have limit x tending to 0, 1 minus tan 5x upon x, right? So now we know, right, limit of fx plus gx, I mean if there will be two functions added or there will be two functions subtracted, then we can change the limit to those functions, right? So it will become limit x tending to 0, x is tending to 0, sin 2x upon x, right, plus limit x tending to 0, tan 3x upon x, right? Similarly on the denominator we can write that part as limit x tending to 0, 1 minus limit x tending to 0, tan 5x upon x, right? Now you know that the formula of sin kx upon x when limit x tending to 0 is nothing but equals to k. So sin 2x upon x will become 2, right? And plus that part tan kx upon x when limit x tending to 0 is nothing but equals to k. So tan 3x upon x is nothing but 3, right? Similarly on the denominator, limit of any constant term is nothing but that particular term, which is 1 minus that particular part is nothing but 5, right? Tan 5x upon x when limit x tending to 0 is nothing but 5, right? So the numerator will become 5 and the denominator will become minus 4, right? So this is nothing but minus 5 upon 4, right? So this is nothing but minus 5 upon 4. So have you understood what am I trying to say, and have you understood about the solution? This is a very interesting and very easy question. Like you have to first check whether the substitution method works or not. If the substitution method doesn't work, I mean if after substituting the value of x you will get some undeterminate form, then you will get any undeterminate form, you have to first here in this particular question you have to divide by x and then you have to separate, and after that you will have to use basically two formulas of sin x upon x and tan x upon x type, and you will get the solution, right? So this is a basic example but very interesting example, right? Yeah, so let's move to the next question. This is also very interesting question, and most probably you will be able to solve this question. So please try to do it by yourself. I will give you some seconds because you have to first think like how we can solve this question, then I will give you the solution, right? Yeah, So think about this question, then we'll discuss it further. So okay, so basically what we can do is first of all we have to write down, first of all we have to check whether the substitution method works or not, right? You have to check each and every times in your brain. So if you put x equals to 0 on the numerator, you can see that will become 0, and also the denominator will become 0 after substituting the value of x as 0, right? So that is nothing but an undeterminate form. So you have to use some other methods, right? So here you can see x sine 7x upon 1 minus cos x is there, right? So basically we can shift that x on the denominator of 1 minus cos x, right? So we can write down this particular function as sine 7x upon 1 minus cos x upon x, right? We can write down these things. Is that right or not? Yeah? Can you tell me, please? Is that right or not? Yeah, that's right, right? So now can you tell me, like can you divide this particular function? Just hold on a minute, just think about it. Yeah, that can be written like that, but there is no issue. But let me write down something different, right? Let me write down something different. Can we divide? We have to divide both sides by x square, right? If we divide both sides by x square, that is also same, right? What we did, but you have to think like that. Since we have the formula 1 minus cos x upon x square, so dividing the numerator and denominator by x square, so then we get what we get? We will get limit x tending to 0 x sine 7x upon x square, and on the denominator we have 1 minus cos x upon x square, right? So here you can see, and that x and x square will be cancelled out, and we have only x right here. So that will become limit x tending to 0. Let me write down this on the left side, because then we will have more spaces. So that is nothing but equals to limit x tending to 0 sine 7x upon x, and on the denominator we have 1 minus cos x upon x square, right? So now we can change the limit into two part, right, on the numerator and the denominator. So the numerator will become limit x tending to 0 sine 7x upon x, right, and on the denominator we have limit x tends to 0, right, limit x tends to 0 1 minus cos x upon x square, right. So now you can see that that particular thing has value 7, because sine kx upon x is actually tending to k when x tending to 0. I mean limit x tends to 0, sine kx upon x is nothing but equals to k, right? Similarly, the denominator value, the value of this particular denominator is nothing but half, right? I have already I will give you the solution, but you have to remember that the value of this particular function is nothing but half. So that is nothing but 7 times 2, which is equals to 14. So the value of this particular limit is actually 14, right? Okay, so let's move to the next question. This is a very common and a very important question, and also very interesting questions too, right? Question 2. So basically here it says that limit x tending to 0 sine x naught x degree upon x, right? So what you have? You have limit x tends to 0 sine x naught, I mean x degree upon x. So first of all you have to check that whether the substitution method works or not. When you put x equals to 0 on the numerator, it will give you actually sine 0 degree, right? So that is nothing but equals to 0, because sine 0 degree is equals to 0. Similarly, when we put x equals to 0 on the denominator, it will give you 0. So it is basically 0 by 0 form. But on the previous formula, we can see that limit x tends to 0, sine x upon x. Here also that particular x tends to 0, and that particular x tends to 0, right? So this is nothing but the same form, right? So most of the student will say that, sir, the value of this particular thing is equals to 1. But that's not true, because on the previous example, what we have noticed it that we have in these three places actually x, but here in that particular place it is actually a degree, it is not a term of x, right? It is x degree. So we can't apply this particular formula here. So what we can do is we have to change this particular degree into radian, right? Degree to radian, right? What a degree to radian says, basically 1 degree is nothing but equals to pi upon 180 radians, right? 1 degree equals to pi upon 180 radian. So can you tell me what about x degree? It's basically pi upon 180 times x, I mean pi x upon 180, right? 180 radian. Is that right or not? Right? So can we write down this particular limit as limit x tends to 0 sine pi x upon 180 upon x? Is that right or not? So it's basically limit x tends to 0 sine pi upon 180 into x, right, upon x. So this is nothing but equals to k, right? And here we have only x. Similarly, we have only x here, and that x is actually tending towards 0. So can you tell me what will be the value of this particular thing? It is nothing but pi upon 180, right? The value of this particular limit is what? Pi upon 180, right? Now you can understand what I actually did. I did basically, since here x degree is there, so we can't apply the formula of sine x upon x, because x and x are here, x degree and x are totally different thing, right? Since this is different thing, so we have to change the degree to radian, right? So we know 1 degree is nothing but equals to pi upon 180 radian. So what about x degree? It is nothing but pi upon 180 x. So after substituting the value of x degree is equals to pi upon 180 into x, it will give me limit x tends to 0 sine pi x by 180 upon x. So which is nothing but limit x tends to 0 sine pi upon 180 into x upon x. So here in the place of pi upon 180, it is nothing but a constant term, which we can say as the k. So it will be sine kx upon x. So that particular value is equals to pi upon 180, I mean the value of k, right? So the value of this particular function is pi upon 180, right? Yeah. So let's move to another question. This is also very interesting question. First of all, what student did some mistake is actually students trying to first they will try to actually use the substitution method, right? So when they substitute x equals to 0 on the numerator, what we will have? We will basically have sine pi, right? Sine pi, because cos square 0 is nothing but we have actually sine pi cos square 0 upon 0 square, right? So sine pi cos square 0 is nothing but 1 square, right? Because cos 0 is 1, so that will become pi times 1 square, I mean sine pi, right? Similarly on the denominator we have 0 square, I mean 0, so sine pi is nothing but 0 and the denominator is 0, right? So basically it is of the form 0 by 0, so it is actually undeterminate form, right? Undeterminate form, right? But what students will trying to do is basically they will use that that sign of something is there, they are just dividing by this particular something and multiplying this by something by x square. Then what the problem they will face is in this particular question is, if they will do that same thing, then what they will see is that will be sine pi cos square x upon pi cos square x into pi cos square x upon x square, right? That they will see. So basically that particular thing is not tending to 0. Actually in the previous formula what we have observed is limit x tends to 0 sin x upon x equals to 1 when this x and this x and this x should be same, and this x should be tending towards 0, this x should be tending towards 0. But here when we put x equals to 0 on that particular angle, right, which is pi cos square x, this doesn't tend to 0. So this is not of the form of 0 upon 0, I mean sin x upon x. So that will not applicable here, right? That will not applicable here. So now you can understand what am I trying to say, right? So let's erase that part, because that is actually a different type of question you have to understand. So how we can solve this question, right? So basically we have to first write down limit x tends to 0, and on the numerator we can write down this cos square x as 1 minus sin square x, right? So that can be written as pi times 1 minus sin square x, right? 1 minus sin square x, and on the denominator we have only x square, right? Similarly, what we can write down this particular thing as, this will be sin pi times 1 minus sin square x can be written as pi minus pi sin square x, right? And on the denominator we have x square. Now you can right, sin 180 degree minus theta is actually on the second quadrant, and in the second quadrant sine should be positive, and since 180 minus theta is there, so it will basically sin theta we will get, I mean sin 180 degree minus theta is nothing but sin theta, right? So that will become sin pi sin square x upon x square, right? So I mean limit x tending to 0, that value we will get, right? So now you can see that when we put x tending to 0, that total part is actually tending towards 0, right? Because sin square 0 is nothing but 0, and 0 times pi is 0, right? So that total part will tending towards 0. Similarly, the numerator part is tending towards 0. Now we can divide by pi sin square x. I mean it will be limit x tends to 0, we'll have sin pi sin square x upon pi sin square x, right? And we have to multiply by pi sin square x because the equality should be there, right? We have to write down that. So basically what we have actually here, you can see that pi sin square x and pi sin square x is there, right? So since x is tending towards 0, so basically what about sin x? Sin x is also tending towards 0, because as x equals to 0, sin x equals to 0. Then what about sin square x? Sin square x is also tending towards 0, right? So if we multiply by pi, then that will become pi sin square x, which is also tending towards 0, right? So first of all we have to just we have to change. Basically pi is there, which is a constant term, so that should be outside of the limit, and now we have to change. By limit x tending to 0, it will be sin pi sin square x, and on the denominator we can write down this as pi sin square x times limit x tending to 0, that will become sin square x upon x square, right? So let me erase that particular let me erase the part which is on the upper side, because that is now worthless, right? Basically because that didn't work, I mean since this didn't work, basically we don't need to think about this particular thing, because that will not give me any solution for that particular problem, right? So that will become pi times, since x tends to 0, we can write down pi sin square x tends to 0, because I have already told you how we can think, like as x tends to 0, pi sin square x always tends to 0. So that will become pi sin square x, okay, tends to 0. We will have sin pi sin square x, and on the numerator we have pi sin square x, right? Times, this particular thing can be written as limit x tends to 0 sin x upon x whole square, and you know, right, limit x tends to a fx to the power l or fx to the power n times something is there, so that can be written as limit x tends to a fx whole to the power n, right? So that can be written as limit x tends to 0 sin x upon x whole square, right? So now you can see that pi times that particular thing is equals to 1, right? That particular thing is equals to 1. So 1 times this particular thing is equals to 1, because this is actually the exact formula as we did. So that will become 1 square, right? So that is nothing but 1 times 1 square is nothing but 1, and pi times 1 is nothing but pi, right? So the value of this particular question is pi, right, which is limit x tends to 0 sin pi cos square x upon x square, right? So now you can understand what I did actually, and this is a very common question, and this is also very interesting question. You have to please remember that you didn't solve by just substituting the value, and you didn't solve by just using that particular formula, which is limit x tends to 0 sin x upon x, right? You have to change that cos square into 1 minus sin square. After that you have to use the trigonometric formula, I mean trigonometric like degree changing formula something, and after that you can actually think about this formula, because the sin something, right, sin x will tending to 0, because as x tending to 0, right? So you have to think about this way. I understand that most of the student didn't solve this problem, because this is a kind of, you know, different type of problem, right? Yeah. Okay, so let's move to the next slide. This is also very interesting question. First of all, just try to solve this question by yourself. I mean I will give you a few seconds. In this particular few seconds you have to think whether you will be able to solve this question or not, right? Then I will give you the solution of that particular question, right? So can you try it by yourself? So I think that's more than sufficient time to that you will think about this particular problem. So let me first talk about you that when you substitute the value of x as 0 on the numerator and the denominator, you can see that the numerator will become 0 and the denominator will also become 0, right? So that is of the form 0 upon 0. I mean this is an undeterminate form, right? So you can't solve this problem by just substituting the value, right? So what can I do actually? Basically here you can see that there is a trigonometric term of cot, right? But we don't have any kind of formula that what will be the value of this particular cot function or something. But we have the formula of sine, we have the formula of cos, we have the formula of tan, right? So we can change that cot by cos by sine. I mean cot theta equals to cos theta upon sine theta. So let me first change this particular cot function with cos theta upon sine theta. So I will have limit x tends to 0. Let me write down on the below of this particular question, because then we will have another, lots of space. So that will become limit x tends to 0. That will be x times cot 4x can be written as cos 4x, right, upon sin 4x, right? Similarly, the denominator, the sin square x should be same, and that cot square 2x can be written as cos square 2x upon sin square 2x, right? So now you can see that if I just write down this particular, I can write down this particular thing as x cos 4x upon sine 4x, right? And that particular thing can written as sine square 2x, right, upon sine square x into cos square 2x, right? So now you can see that if we put x equals to 0 on that particular cos 4x, that will give me 1, right? That will not give me any 0. Similarly, if we put that particular x equals to 0 on that particular part, that will not give me any kind of 0, right? I mean it will give me a non-zero term, right? So let me first change that two functions on the right side. So that will become x sine square 2x upon sine 4x, and on the right side we have cos 4x upon cos square 2x, right? So now you can see here is actually two functions, one is this and another is this, right? So we can change the limit. I know, you know, right, the formula. So basically limit fx into gx can be written as limit fx into limit gx, right? And x tending to 0 should be same, like, so it will become x times sine square 2x, and on the denominator we have sine 4x, right? And on the right side we have limit x tending to 0, sorry, cos 4x, it's cos 4x, okay? And on the denominator we have cos square 2x, right? So now you can see that here sine square function is given and here sine 1 degree function is given. So basically we have to divide this particular function by x square, right? So if we divide this particular function with x square, so it will become I mean just hold on a second. I have to think about this question. Basically, is there any mistake happened or not? Just wait a second, please. I think there is something. I mean we have to take that particular sine square, right? Just wait a second. X cos 4x sine square x, and on the numerator, like, cos x upon cos square x is there, so x sine square 2x is there, and we have on the denominator, which is sine 4x into sine square x, right? It is not only sine 4x, we have sine 4x times sine square x, right? On the denominator we have sine 4x times sine square x, right? So similarly it will be sine 4x into sine square x, right? So if we divide by this particular thing with x cube, right, we have to divide by x cube. So it will have sine 4x into sine square x upon x cube, right? And on the right side, if we put x equals to 0, it will give me cos 0 upon cos square 0, which is nothing but 1 upon 1 square, right? So that will become limit x tends to 0, you know, x and x cube will be cancelled out, so we have sine square 2x upon x square, and on the denominator we can change that particular thing with sine 4x upon x into, times sine square x upon x square, right? So now you can see that there is actually three types of different function is given to you. So you have to first change the limit. So I can just write down in a one single. Sorry for the disconnection, because there's some glitch happened or something. So that will be limit extending to 0 sine 4x upon x, and on that denominator we have limit extends to 0 sine x upon x, that particular thing whole square, right? Because you can see when we change the limit, it will be limit extending to 0 sine square 2x upon x square, and that sine square 2x upon x square can be written as sine 2x upon x, that part whole square. So if you substitute the limit inside that particular square part, it will give you sine x tends to 0 sine 2x upon x, that part whole square, right? Similarly on the denominator we have limit of fx times gx. There are two functions, right? So we can change that functions. After changing the function, we have limit x tends to 0 sine 4x upon x, and on that right side we have limit x tends to 0 sine square x upon x square, right? So that can be written as limit x tends to 0 sine x upon x, that part whole square, right? So that is nothing but equals to 2, because you know the formula of sin kx upon x when limit extending to 0, right, which is nothing but k, right. Similarly here it will be 2, so on the numerator we have 2 square, and on the denominator that part is nothing but 4, and that part is nothing but 1 square, right, because sin x upon x when limit extending to 0 is nothing but 1, so that will be 1 square. So 2 square and 4 will be cancelled out, because 2 square value is nothing but 4, so it will be 1, and on the denominator we have 1 times 1 square, so that is nothing but 1, right. So the value of this particular limit is actually 1, right, the value of this particular limit is actually 1, right. So okay, then let's move to, there are actually 3 problems given to you. Let's try to solve these 3 problems. So basically, why 1 minus cos x upon x square is equals to half when limit extending to 0, we will prove in this particular lecture. So basically we have no formula like cos x or something. I mean just if you substitute the value, it will give you 1 minus 1. I mean cos 0 is nothing but 1. So on the numerator you will have 0, on the denominator you will also have 0, right. So it is of the 0 by 0 form, right. Since it is 0 by 0 form, that means it is undeterminate form, right, UF or something, indeterminate form. So if it is undeterminate form, so that can be written as limit extends to 0, you know, right. 1 minus cos theta can be written as 2 sin square theta by 2, right. 1 minus cos theta is equals to 2 sin square theta by 2, right. So similarly 1 minus cos x can be written as 2 sin square x upon 2, right. Similarly on the denominator what we have is actually x square, right. So basically 2 should be outside of the limit, so we have 2 times limit extending to 0 sin square x upon 2, and let me write down this particular x square as x upon 2 whole square, and so we have to multiply by 4 because 2 square will be 4 and here there doesn't have any 4, so after cancelling that 4 we will have the previous function, right. So 1 by 4 should be outside of the limit, so that will be 2 upon 4, right. So what we will have actually limit extending to 0 sin square x upon 2, and on the denominator we have x upon 2 whole square, right. So 2 upon 4 is nothing but half, right, 1 upon 2, and that can be written as limit extending to 0, that can be written as sin x upon 2 by x upon 2 whole square, right. So can you please tell me, as extending to 0, what will be the value of x by 2? I mean x by 2 will tending to what value? It should be tending to 0, because as extending to 0 means x is almost equals to 0. Since x is almost equals to 0, then x by 2 should be almost equals to 0, right. That, I mean if x tending to 0, then x by 2 should be tending to 0. So that can be written as limit x by 2 tending to 0, and we have sin x by 2 upon x by 2, that part whole square, right. So basically we have to put the limit inside the function, right. So that will be half times limit x by 2 times 0 sin x by 2 upon x by 2, that part whole square, right. So now we can see x by 2, x by 2, x by 2, and that particular x by 2 tends to 0, that particular x by 2 tends to 0. I mean so that particular thing is equals to 1, right. So it will become half times 1 square, right. So that is nothing but half times 1, which is nothing but half, right. So now you can understand why this particular limit value is actually half, right. So limit extends to 0, 1 minus cos x upon x square is nothing but half, right. Okay, so let's move to the next question, which is limit extends to 0 sin 3x upon 2 minus root under 4 minus x. So basically when you put x equals to 0 on the numerator, it will give you sin 0, which is nothing but 0, and if you put x equals to 0 on the denominator, it will give you 2 minus root 4, which is nothing but 2 minus 2, which is equals to 0. So the function is actually of the form 0 upon 0, right. So this is the undeterminate form, right? So how can I solve this? Basically here you can see we have to rationalize this particular part, right? So if you rationalize this particular part, so it will give you 2 minus root under 4 minus x times 2 plus root under 4 minus x. Similarly, we have to multiply the numerator by 2 plus root under 4 minus x, right? So now you can see if we put x equals to 0 on that particular function, which is 2 plus root under 4 minus x, it will give you non-zero value, right? Since it will give you non-zero value, we can actually take that part outside of the something, right? I mean we can change this limit, right? So it will be limit extending to 0 sine 3x upon, that will be a minus b times a plus b, which is nothing but a square minus b square. So that will be 2 square minus root under 4 minus x whole square, right? And on the right side we have only 2 plus root under 4 minus x, right? 4 minus x. So this is actually the function. Now we can check, I mean we have to put that particular thing as suppose sine 3x upon, it will be 4, right? And on the right side square root will be cancelled out and it will be 4 minus x, right? Similarly, if we change the limit, it will be limit x tends to 2, it will be 2 plus root under 4 minus x, right? So that is nothing but limit x tends to 0, that 4 and minus 4 will be cancelled out and we have sine 3x upon x, right? And on the right side we have limit x tends to 2 plus root under 4 minus x, right? So that is equals to, here you know, right, the value of sine kx upon x when x tends to 0 is nothing but k, so that will be 3. Similarly, if you put x equals to 2 on that part, it will give you 2 plus root under 4 minus 2, which is nothing but 3 times 2 plus root 2, right? 2 plus root, let me hold on, there is no x tends to 2, it is actually x tends to 0, right? So it is actually x tends to 0. So x tends, wait a second, yeah, that will be x tends to 0, that will be x tends to 0. So it will give you 2 plus root under 4 minus 0. So that is nothing but 2 plus root 4, right? So that is equals to 3 times 2 plus 2, right? 2 plus 2. So that is equals to 4 and 3 times 4 is nothing but 12, right? So the value of this particular limit is actually 12, right? Yeah. So let's move to the next question. I think we crossed our time boundation or something, but since we started from late, but let me give you some hint so that you can try to do by yourself, right? First of all, what you have to do is basically you have to check first whether the substitution thing will be applicable or not. I mean, that will not be applicable after substituting the value. You can check. You have to write down this 20 to the power x as 5 times 4 to the power x, right? Minus 5 to the power x minus 4 to the power x plus 1, and sine square 5x will be as it is, right? Then after that, 5 times 4 to the power x can be written as 5 to the power x into 4 to the power x, and we have minus 5 to the power x minus 4 to the power x plus 1, and on the denominator we have sine square 5x, right? So here in these two functions we can take common 5 to the power x, so that will be 5 to the power x times 4 to the power x minus 1, and on that two parts we can take common negative 1, right? So that will give you 4 to the power x minus 1, right? So on the denominator we have sine square 5x. So if I will take common 4 to the power x minus 1, so that will give me 4 to the power x minus 1 into 5 to the power x minus 1 upon sine square x, right? Now you have to divide the numerator and denominator by x square. So if you divide the numerator and denominator by x square, so you will have 4 to the power x minus 1 by x and 5 to the power x minus 1 upon x, right? And on the denominator we have, it's basically sine square 5x. So it's basically sine square 5x upon x square, right? That means sine 5x upon x whole square, right? So that will give you log 4 base e, that will give you log 5 base e, and that will give you I think 5 square, right? So then after that you have to try to minimize these things, or try to taking something, right? I mean you have to try to make this easier form of a constant term, then you can easily find out the value of this particular thing. This is for the hint, and in the next lecture, in the upcoming lecture, we will solve this question, and we will try to learn some new theorems and new formulas, which are basically maybe L'Hospital's rule, sometimes it is called DL rule, or sometimes it is called L'Hopital's rule, right? This is very interesting. This is very interesting theorem or theorem, and we will learn about the squeeze theorem, or sometimes it is called the sandwich theorem, and we will solve some problems related to this topics. And after that, there will be around 3 to 4, minimum 3 to 4 lectures based on the previous questions of JEE Mains and JEE Advanced, right? So stay tuned with us and try to attend the lecture by systematically, so that you will learn a lot of things. And thank you for watching this video, and thank you for joining, and we will learn lots of things in this particular channel. And thank you for joining. We'll meet we'll meet soon, right? Okay, thank you.